Jai Hind everyone. Myself is Nikhil Kumar. I'm the faculty of IT department in Akgec Engineering College. Today I have the lecture in the DSTL, Discrete Structure and Theory of Logic, that is the code BCS 303. Till now we have, basically it is the series of the DSTL. Till now we have discussed already the set relations functions already and the type of the relations already discussed. So in this lecture we focus on the partial ordered relations. Basically that are the part of the set elements, and the partial order relations contains the a special property of the relations. So what's happening here, a relation R on a set S is called a partial order on a partial order of S if it have the property, that means it have the property of the reflexive, antisymmetric and the transitive. So we can say that is the consider is the that will be considered in the partial order relations. We particularly identify all the relations properties of the reflexive, antisymmetric, transitive, symmetrical, asymmetrical, and same here the irreflexive. So we discuss all the properties individually. So particularly if these three properties, that means reflexive, antisymmetrical and the transitive properties satisfy in the relations diagram, so we can say that is the partial order relation, that is in short that is the Poset. A set S together with a partial ordering R is called the partial order set and it is known to be a Poset. So in short form, the partial order relation or the set is known to be the Poset. And we know very well what is the reflexive nature of the element. Let's suppose if a element is indicated to itself, that means it is mapped, the pre-image contains its by default, then it is known to be a reflexive natures. In the case of the antisymmetry, that means if A, B belongs to R, where A, B are the elements that are the part of the relations R, then in that case, particular case, then B, A will not be the portions of the R, that is known as the antisymmetrical. Then the transitive relations, we know very well that let's suppose A R B and B R C, then there should be, we will check that A R C will also be present, then it is known to be a transitive nature. Because when A R B, that means that A are connected with the B element and B are relative, have the relations to the C, then by default if A R C is also present in the given relations, then we can to say then that is the transitive nature. So these three properties present in any relations by checkout, when we identify that these three properties exist, then we can say that it is the partial order relation, or the we can say that is the Poset, that is the Poset, partial order set. In different way we write down here with the explanation of this property. So we come to the numerical questions. The first question is, consider the relation R where R relation contains some ordered pair. We know what is the ordered pair. Basically the ordered pair is the element with the connected element, that means let's suppose one is present, then a symmetry that a connected element with using that element is also the connect in the pair, also present in the relations, then it is known as the ordered pair. So basically let's suppose the given question is 1 1 2 2 3 3 4 4 1 2 and 2 1 are present in a given relation on the behalf of the set element that are present, that is 1 2 3 4. Then we have to check, determine if R is an antisymmetric or not. So for that one, we know very well that according to the property of the antisymmetrical, if xy belongs to R, then yx and yx also be present, then it should be x equal to y, then it is known to be antisymmetrical. Otherwise xy belongs to R, then yx should not be present, that is the antisymmetric. But only one case that yx will be present, then in that particular case x should be equal to y, that means both the elements should be equal, otherwise it will not be the antisymmetrical property. So at the point of the antisymmetrical proof, what we will do, we only check that if x belongs to y, then both should be the equal element. That means x should equal to the y element, otherwise they are not present in the reverse order y comma x. So we take the elements, just take first pair, ordered pair 1 1. That means 1 1 both are the identical element and the reverse order also be present. So this is proof that this is the 1 1 element is present, so that we can say that it is the antisymmetrical element. 2 2 3 3 4 4 have the same thing, 1 comma 2 and 2 comma 1. So what we know, the element 1 comma 2 is present and 2 comma 1 is also present, but we know very well that 1 is not equal to 2. So in that case we can identify that 1 is not equal to 2, so R is not antisymmetrical. Firstly, the question is that determine R is antisymmetrical or not. So we identify that R is not the antisymmetrical. So I hope so that everyone got the point that what I want to say. We take the second one question, that let R be a relation on the set element with the set element is A equal to 1 2 3 defined by R, that is 1 1 2 2 3 3 and 1 2. Is R antisymmetrical? Then we have to check by using the principal module. By using this principle, we take the element, that is the relation element 1 1 2 2 3 3 and 1 2. So 1 1 is also be the identical, 2 2 also identical, 3 3 identical, 1 2. In that particular case 1 2 is present, but 2 1 is not the present element. So if 2 1 is not present, then we can say that it is the antisymmetrical also, because if let's suppose 2 1 is also present, then we have to check that 1 is equal to 2, but here in that particular case the element 1 comma 2 is present, but 2 comma 1 is not present. So we are ensured that that is also the antisymmetrical. So we identify two things. Firstly, if A comma B is belongs to R, and then we will check that P comma A is also be present or not. If their reverse order is also be present, then we can identify. Then we identify that both the elements are equal or not. If both the elements are equal, then we can say that is the Poset partial order, that is the antisymmetrical. Otherwise, we can say that is not the antisymmetrical. Okay. Now the time is to prepare the hash diagram. So what is the hash diagram? So basically the hash diagram is based on the concept that let's suppose the Poset element exists in the given relations, then we can identify that we can prepare the hash diagram. The hash diagram is a graphical representation of a partially ordered set Poset showing the order relation between the element in the simplified way. So without taking the too much examples and the concept, we can say that we prepare the hash diagram. Hash diagram is basically the representations of the Poset partial order set in the graphical representation. So we can say if the relation is reflexive, antisymmetrical and transitive, so we can prepare the hash diagram for a given relations. So the minimum criteria is to design the hash diagram is the to be present in the availability of the Poset partial ordered set. So what are the key features of the hash diagram that are be mentioned here? That should be element represented as a point over the vertices. That means in the general diagrams of the representations of the relations, we identify any element with the circle value. Let's suppose A is connected with B, so we represent in this formation. But in the case of the hash diagram, there is some different properties. That means we will only represent the element with the single entity values. That means the circle will be missing. We will not use the circle value. That means circle identical to represent the particular element. So we will not use the circle value. We only write down with the element. That means it will be represented A. The order relation, if element A is less than element B in the poset, there is a line connecting A to B with a placed lower than B. That means the proper a specific property. Let's suppose we have the relations in the formations of A or B, and the relations that are mentioned here, that the property, that means the A is connected to B with the relations the less than property. So in that particular case, we can say A less than B. So we will place A followed by the B's element. B's value will be the above position to the A element. So that is mentioned in that formation. So element order relation. The third one is the transitive omitted. Let's suppose if A is less than equal to B and B is less than equal to C, in that particular situations, the diagram will not include a direct line from A to C. That means we will disconnect the transitive relations. Since that relation is implied, no arrow will be permitted. Unlike directed graph, a hash diagram does not use the arrow because the vertical position higher to the greater value and lower to the lesser implies the directions particularly. What does it means? In the relations diagrams, we represent the particular this one formation. That means A is connected to B, but in these formations, B is not connected to A. But when we prepare the hash diagram, we already maintain the relations through the bottom to top connectivity. So we avoid and we will not use the proper directions. Just like here, we avoid the directions because the directions is already mentioned in the connected point. That means the bottom is will be the less positions and the top will be the higher positions. So we connect the element in such a manner that when we use at the lesser position, at the bottom positions, that means the element is less than the higher position. So we avoid the arrow because that is already exist in the bottom to topper positions. How can you construct a hash diagram for a given set and the relations? So what we will do, firstly, we will use a element rather than the particularly circled value. We use the identical element. That means we use A other than the this one. So we will use just wait. We will use this element other than this one. So this is the formations. So identify the element and the relations. We properly use the elements in that formation. Second one is the remove the reflexive and transitive relations. That means if let's suppose there is a connection between A to A, so we avoid that one. That means we will avoid the self loop property, and we also remove the transitivity. So let's suppose A less than B less than C. So only draw the direct relation from A to B and B to C. We avoid the A to C connections. The two most important things that I have already discussed here, that we remove the transitivity. Second one, we remove the reflexivity. That means the identical element that represent the direct self loop, we avoid the self loop and the transitivity relations. So next one is the determine the vertical position. That means place the element such that if A less than equal to B, then A is position lower than B. We already discussed. Connect immediate relations. That means let's suppose A to B and B to C connections have present, then we will use firstly A to B, then B to C. That means we will avoid A to C connections. So whatever is present in the given questions, we will use as it is without transform in different way. but we avoid the reflexivity, that means the self-loop and the transitivity relations. The difference between the hash diagram and the directed graph. In the directed graph, there is the proper formations of the directions is mentioned and the element is circled. Let's suppose A is here, B is here, so it will be represented here, and the element may or may not be bidirectional, self-loop, and the written in the horizontal way. But in the case of the hash diagram, what we will use? We use the formations of top to bottom. That means bottom to top values will be present. In the hash diagram, we avoid the concept of the horizontal directions. And the other one thing is that we also remove the directions mentioned because it will be the bottom to top, and we also avoid the circle value on the particular element. So no arrow is present, omission of the transitive edge. So hash diagram is prepared on the basis of the Poset partial order set, and it in the short form it is written as the Poset. The hash diagram, let's suppose we have the hash diagram with the element 1, 2, 3, 6. So how we will prepare the hash diagram with the divisibility relation? Let's suppose the divisibility relation is not mentioned. So how we will prepare? When the divisibility relation is not mentioned, so how we will prepare? In that particular case, we avoid the, if the relations is not mentioned, that means that how they are connected, that means how the one is connected to 2, 3, 6. By default we take the divisibility relations. So in that particular case, the short form, that means the lower element in that particular element is 1, and we know that 1 have the multiples than 2, then we will use 3, and then we will use 6. 1 is the 2 comes in the multiples of 1 and also 3. So but we will not form 3 here. We will not move 3 here. Why we will not move here? Because we know very well, because if we prepare here, so what will be the positions? Yes, just wait 1 minute. 2 is not the multiples of 3, so we will place how will be the formations. Yes, 1 will be here, then we have the 2 multiples, 2 and 3 will be here, because it will take the same positions, same level. 2 and 3 will be at the same level, then we will use the 6 at the top level. Why we did not use 6 here? Because we know very well, because 1 is the multiple, 6 is the multiple of 1, so it can be used here. But 3 is also contains the element in the form of the 6, because 6 is also the multiple of 2 and 3 also, and by default it is considered as a 2 element. 6 is multiple of 2 element or the individual 3 elements, so we will not place 6 position here, because 6 position is be placed to the top of that 2 and 3. So we will use, we avoid this one, and we follow that one. So this is the right one answer. How we prepare this hash diagram? Because 1 is the less element, that means is present at the bottom at the base value, then once have the multiples of 2 and 3, so we place at the same order. Then 6 is placed at the top of the position, so we will place, because 6 is the multiple of 2 and 3 also, so we place the value of 6 at the topper side, at the top of the side of the higher order from the 2 and 3, so we place such scenario. So this is the hash diagram. So next one is the element is a 2, 4, 8 and 16. So with this divisibility relations, how we will prepare? We prepare this scenario by the relations 2, 4, 8, 16, and the divisibility relation is prepared. So firstly we will maintain 2 element here, then we know that it is the 4 element will be prepared, then we will prepare the 8, then we will prepare the 16. We 2 individual element will not be positioned at the same level because each one have the contains the multiples of the other one. That means 2 will be divisibility, prove the divisibility, then 4 have the multiples of 8 and 8 is the multiple of 16. So it is the hash diagram. There is no any transitivity is mentioned. So for today class, we take the elements, that is the we discuss the Poset property. We also understood what is how we will prepare the partial order relations. What are the property of Poset element, that means reflexivity, antisymmetric and transitive. What are the hash diagram and how we will prepare the hash diagram from the given Poset element. That means what is the connectivity, that how we will prepare the hash diagram. We take some examples. So for today I think that it is sufficient to be understood. All the elements is discussed, all the questions is discussed. So we will take the next lecture for understood the next concept. So thank you class.